Hello everyone. In this video, we're going to see the question, delete nth node from the end of the given linked list, right? Let's just see what this question demands. So you'd be given a linked list and an integer n. And what would be the task? The task would be to delete the nth node from the end of the given linked list. So let's just see what it means, right? So let's just say you've been given this linked list, 2, 3, 1, 7, and 5. And you've been given n as 3. So you have to return the third node from the end of the linked list, right? So let's say this is first node from the end of the linked list, this is second node, and this is third node. So you have to delete this node such that your answer linked list, it becomes 2, 3, 7, and 5. Make sense? So in a way, if I tell you that my length of the linked list is 5, you understand that I have to delete 5 minus 3 plus 1, that is third. In this case, it was third from the beginning as well. But if I take the example to be, let's say, 1 second. Okay. I take the example to be 2, 3, 1, 4, 7, 6, and I will increase from here 5, let's say. And now n is given as 3. So this is my first node from the end, second node from the end, third node from the end. So I have to delete this node, right? Now, what is my length of the linked list? The length of the linked list is 1, 2, 3, 4, 5, 6, and 7. So what did I say? 7 minus 3 plus 1. I have to delete fifth node from the beginning. Let's check. Is it true? So this is first node from the beginning, second node from the beginning, third node from the beginning, fourth node, and fifth node. Makes sense? So I have to, in a way, say that if I reach my L minus nth node, that is, if I reach this node, I have to point this node's next pointer to this. And then delete the memory address taken by the node that I have to delete. Does this make sense to everybody? Are you able to relate back to the things? Right? So this is what we have to do. And right. So in this, let's go with the approach 1. Let's say I have 1, 2, 3, 4, 5, 6. Make sense? And the n is 2. This is my question statement. That means I have to delete this node. So what do I do? At first, I take my count variable and initialize to 0. I move one step ahead, increase count to by 1, and when I reach here, I have my count set as 6. So I know my length of the linked list is 6. That is the way to find the length of the linked list. So now that I know the length of the linked list and I know n is 2, I have to iterate until I reach L minus n. That's it. That is to say, until I reach my 4. Or I will just do one thing. I will take another as temp as 4, right? And then I will keep moving until I reach temp as 0. So I start here, my temp is 4. And then my temp becomes 3. Temp minus minus. When I'm here, it becomes temp as 2. Minus minus. Temp 1. Temp becomes 0. Now that I am here, I check and then I move this pointers. I move a pointer, let's say pointer, and then I move pointers next is moved to pointers next. In a way, this next is broken and this next points here. Make sense? And then I delete my what? I delete what? Let's say I will make my del node is what? Pointers next. Then I delete my del node. Make sense? Right? Okay. That is my approach 1. And if you talk about the space complexity, it is big of 1, Now let's talk about the time complexity. The time complexity is big O of n. Why big O of n at first? Because we traverse to find length. Make sense? And then big O of L minus n for this pointer's traversal. Make sense? This is my pointer's traversal. Now what I have to do is, now I have to get to a better approach. Let's just say I'm getting up to a better approach. So what I'm trying to do, I'm trying to make this thing go into one thing, right? So let's just say I have been given 1, I have been given 2. Same thing again. So what do I do in this case? I take 2 pointers, fast pointer, slow pointer. I move my fast pointer by n steps. Now what is n here? N was given to me as 2, right? So n1, n2. My n reaches this ways. Make sense? Now this is where my fast pointer is, right? I have to move my pointer until, so what was this? N is 0. Okay, fast pointer moves, N is 0, fast pointer is here, head. N is 1, fast pointer is here. Now N becomes 2, my fast pointer reaches this place. So I get my fast pointer here and my slow is at the same time here. Now I move them one by one step. So when my fast pointer, let's just say we're moving it, okay? So your fast goes here, your slow comes here. Your fast goes here, your slow comes here. Your fast goes here, your slow comes here. So when your fast pointer is at your lth node, right? Your fast pointer is at your lth node, your slow pointer is guaranteed to be at your L minus nth node. Make sense why? Because the difference between them is n, right? So what you do, you maintain a difference of n at first by moving your fast pointer by n, and then you start moving them sequentially one by one together. So this difference of n between them is maintained. So when the fast reaches n, where does your slow reaches? Your slow reaches L minus nth node. You don't have to worry that I could not think of this approach, that approach. You don't have to think because these are not intuitive, right? The above approach was intuitive, but this approach is built upon that. And when you do more questions, when you see more questions of this type, this intuition is going to build. But right now, just try to, just try to see through it. So what happens? You move your fast. Okay, you keep your slow at 0. You move your fast to nth node. Then what you do? You keep moving them together. 1 and 1. 1 and 1. 1 and 1. This difference, the difference was there. How much? The difference was n. This difference is maintained. So when your fast node reaches your lth node, where will your slow reach it? Your slow will guaranteed be on your L minus nth node. Make sense? And then is where you do this. You move your slows next to slows next. Make sense? And the way this 5 was deleted here, you delete this 5. I hope this makes sense. You're good with the approach and the time complexity. Big O of n because of your fast pointer. Your fast pointer is going to traverse your entire linked list. And your space complexity, big O of 1. Now let's just come to the coding part. You don't have to worry much on if you could not derive this intuition from yourself, because it's a little tough, or I would say it's built upon some other solution, right? So if you were able to even get approach 1, that is perfect, that is fantabulous, I would say. And these kind of approaches that are built upon the intuitive approaches, you get them after you've done a good amount of questions, after you've seen them, after you've read them somewhere, after you've read the approach, after you've viewed the approach once, then is where this intuition, it starts to build up in your own mind when you see such kind of questions. Okay, so it's okay if you were not able to, intuitively get to this approach. And if you were able to get, then you are a genius. Then let's just study the code part. node star, delete nth from end. Node star head is being given to us. We make a slope and obviously your n will be given to you. Right? And then you make your slope pointer pointing to head. You make your fast pointer that points to head again. Then you move your fast pointer by how many steps? By n steps. So for int I is 0, I less than n, I plus plus. Fast moves to fast next. Okay? Make sense? And we will check one thing here. If your fast becomes null, right? If your fast becomes null, that is your n that is given to you is your length of the linked list. Make sense? The n that is given to you is the length of the linked list. Then what do you have to delete? You have to delete your head. So what do you return? You return heads next. Make sense for this one? If your deletion is for head, right? If you have to delete nth node from the end because, and it says the nth node from the end stands for, it stands for your length of the linked list. That means you have to delete the head. And if you delete the head, you don't have to do anything. You just return heads next. That's it. But if it is not the case, what do? We'll move fast while fasts next is not equal to null. And what do? We move slow to slows next. We move fast to fasts next. Make sense? Yes. And now we know when fast reaches the end, slow is to L minus N. So what do? We store slows next. Node star del node points to what? Your slows next. And then your slows next points to what? Slows next. So your slows next points to your slows next, and then you delete your del node. Make sense? And you return your head. Did we talk about the time complexity? Yes. Make sense? If you still have any doubts, if you still have any concerns, please make sure you're making use of the comment section. Please make sure you're making use of your Google form link that is attached in the description. If anything, if any question you still have doubts on, or you want me to re-clarify, or you have another question that does not belong to linked list, still please feel free to put that question in your G form, and I'll take up that question irrespective of any data structure it belongs to. Right? With this, yeah, if you were able to understand the question, if you were able to extract something out of the video, if you found the video helpful, just go and like the video and subscribe to the channel. Thank you, everybody. Bye-bye.